Hi everybody, welcome back to the bench. Well, this really wasn't intended to be a video. This is me playing around on the bench, and as I got into it more and more, I decided, well, maybe this might be something interesting to some of you for me to do one of my random videos. So that's what this is. Let me start it. You know, you got to have a story in my videos, right? There always has to be a story. So here's the story. First of all, my son and I were discussing, he's going to college for electrical engineering, and we were kind of getting on the subject of oscillators and how you find oscillator circuits everywhere in electronics, all different types. And so I started thinking about it, and I started thinking about the different components of an oscillator, and I said, maybe I'm going to draw one out. So I sat and I sketched this really poorly drawn schematic out of a Colpitts oscillator. I wanted to kind of think about the influence of each part on the oscillator. And then I thought about it and I said, why don't I just build one and see what it does? And the reason I decided to do that was I was kind of inspired by a video from another YouTube creator. So I was watching a recent video by Fran Blanche, and I'm sure a lot of you already are subscribed to her channel, and if not, you should. I don't know her, but I have followed her channel for a long time, and I really admire the work that she does. So if you get a chance, check out her channel. She did a preliminary video on an electromechanical frequency gauge, and then she had so many comments and questions that she decided to do a follow-up. And in the follow-up, she made a comment that really inspired me. And the comment was, somebody had said to her in a comment, you could just Google that. Why don't you just look it up on Google? And she said, and I'm paraphrasing, she basically said, you don't really learn when you just Google something and just get an answer all the time. The best way to learn is, she said, the way I like to learn is by doing it and experiencing it. What a wonderful answer. And I am 100% on board with that. I'm the same way. I know there's things you can look up in a book, and I know there's things that someone else can just tell you the shortcut to it, but you really don't learn all about how something works until you experience it and work with it. So that's why I decided to build this circuit. It then led into, how do different transistors affect this circuit and why? So that's where we're at right now. And I came up with some really interesting things that I found, and I thought I'd share them with you, and then give all you other folks out there, especially you guys that are a lot smarter than me, to add your comments to it, to what we're finding. Now, I've gotten comments on a lot of my videos, especially when I'm working on either a radio or an amplifier, about, you know, how important is it to use this, that, or the other type of transistor, and does the type of transistor even really matter that much? How does it affect the circuit? And that was those are interesting questions, and I kind of don't go into a lot of detail. I'm just like, use this one, and I did. You've heard me talk in other videos a lot about things like transition frequency, gain, slew rate, all these different things, how they're interrelated to one another. But I never really gave you an idea of what that does to a circuit. So this is a really simple circuit, and what we're going to do, this is about a 1 megahertz, and when I say about, you're going to see why I say that, about a 1 megahertz oscillator. Why 1 megahertz? Well, number one, by making this a 1 megahertz circuit, it's well within the transition frequency range of all of the transistors we're going to test. So that's number one. Number two, it's in the RF range. It's just above the IF range. And what we're seeing here will also affect the audio range. So it's kind of a good frequency to try these out. Now what I'm doing is I'm not going to change the circuit at all. All we're going to do is swap out the different transistors, and we're going to look how it affects the waveform and the frequency of the output. Now, if you notice on the little schematic I have up here, I have two test points. One is before the capacitor and one is after. This is just an output decoupling capacitor. I'm not going to look at TP2 because if we look there, we would not see the bias voltage and we would not see the offset of the frequency, if that makes sense to you. So I just wanted to add it in there. I can show you at the end of the video what it looks like, but we're looking at TP1 throughout this video, and I'll show you why in a second. If I am going to show you just the idle point of this little amplifier circuit, I'll just pull C3 out. By removing C3, then there's no oscillator. The oscillator can't influence the base of the transistor. All right, now that we have that all kind of straightened out, let's put some transistors in it and see what they do. You can see from right to left, this is an NTE107, and this transistor, you can see, is good for transition frequency is 1 gigahertz. So this is a very high, it's a UHF oscillator transistor for tuners, okay? So this would, you'd see this in like a television tuner, like in a UHF TV tuner or something like that. So this is a really good transistor. We also have a KSC1845, which is a low noise transistor that we use an awful lot. You see us use these quite often in audio and high-end audio when we're restoring audio gear because it's low noise and it's a really good characteristic transistor. They have good gain and so forth. 2N2222, 2N5551. Here's a 2N3904 from eBay, and it's a cheap Chinese one, and we don't even know if that's an authentic one. I threw that in there. Here's an actual Motorola 2N3904. Here's a BC547, and then I even put a PNP transistor, and it's germanium, to see will it work in the circuit. Honestly, you can take and put a PNP or an NPN in this circuit. All you do is to make a PNP work in this, you would just swap the emitter and collector around and the circuit will work just fine. And I'll show you that later. So the first thing that's in here is this NTE107. And it's a UHF transistor designed for high frequencies. Let's look at the waveform. The first thing I'm going to do before I move the camera up, I'll show you, I'm going to remove this little capacitor. That's the coupling capacitor for the base. So I just removed this C3 right here. So all this thing's just going to sit at a DC level. I'm going to turn this on, and if you look down here, I have the power supply set to about 12 volts. It's not super important, but. And if you look here, you pretty much have the circuit turned on. You have just about, not quite 12 volts sitting there. So it's saying channel 1 max 12.4 volts. So it's sitting at full voltage right now. So let's see what happens when I put that. I'm going to turn the power off so I don't short anything out. And I'm going to put that little coupling capacitor back in. I get a lot of commenters. It's a decoupling capacitor. It's a coupling capacitor. It's a capacitor. It couples the two sides of the circuit. I'm not going to get worried over semantics. All right. Unit on. And you can see we get a waveform. Now, you're not going to have a perfect sine wave because different things in this circuit affect the signal. And you can see on the positive going portion, it looks pretty good. On the negative going, it's got some distortion at the bottom, pretty bad, and a wee little bit over here. The thing that is interesting is I have 12 volts is all we're worried. It's a single-ended circuit, 12 volts. But what is our peak-to-peak amplitude? It's 23.4 volts, or 23.8 is your max. So it's doubling the actual voltage. And it's doing that through those capacitors. And this is not really a tutorial on oscillators. I don't want to get into that. I want to look at what the transistors do to this circuit by swapping out a different kind. Because once again, a lot of times people will work on a receiver, like a tuner or something, like a radio, and you'll swap out a transistor with one that you think is good, and the radio doesn't work properly, or the radio you can't align it accurately. Why does that happen? We're going to see. So here's that UHF, and it's pretty good. And look at the frequency. 1.03 roughly megahertz. So it's a 1 megahertz oscillator plus a little bit. All right, let's put another transistor in and see. This next transistor is the KSC1845, and this is one you see in audio circuits all the time that we use as replacements, especially when I do the Pioneers and the Sansuis and Marantz. You see these transistors a lot. So let's turn the power on and take a look. What do you see? Well, first thing you notice is our amplitude. This looks a lot cleaner up here. However, on the negative side, do you see what it's doing? It's clipping off a lot more. And you're even getting a teeny little bit of oscillation down there. So you can see how it affects the circuit. Also, what happened to our frequency? It dropped way down, and from 1 megahertz, it's down to 890 megahertz roughly. So it's 120 megahertz slower. I didn't change anything in here. I changed nothing but the transistor. Now let's look at the 2N2222. All right, here's the 2N2222. What happened? If you notice, it's even going below the 0 volt line there because it's oscillating so bad. And you can see what happened to our gain. Instead of being double the 12 volt input, look, it's way up now in the 33 volt range. And look at our frequency is 938 kilohertz, so it's not 1 megahertz. So there's all kinds of crazy things going on with that 2N2222, isn't it? Now let's look at a 2N5551. That's also a pretty high powered small transistor for what it is. And these are all really common you see in electronics, common transistors. So let's put the 5551 in. Okay, here's the 2N5551. And it's similar to the 2N2222, isn't it? And it's going off scale, isn't it? Look at that. So it's not even reading the whole waveform. Look at that. There we go. And frequency is that way down, 853 kilohertz. All right, let's go to the next one. All right, the next one here is our 2N3904 from eBay. This is just a generic transistor that, you buy 100 of them for $1 or whatever. And you can see the gain is lower, and it's still clipping a lot at the bottom. And you do have this oscillation down here. And the frequency is still not 1 megahertz. It's 955 kilohertz. Next is the 2N3904, the Motorola, the good one. And you can see it's not that much different. However, look at the frequency. It's where it's supposed to be. You do have a little bit of ringing here at the beginning again, at the bottom. But once again, that's very close to that UHF transistor that we started out with, the NTE107. They're both 2N3904s, but are they really? Are they really the same? Next is a BC547B, another very common transistor. And it doesn't work because I have to put it in the right way. Sorry. There we go. And once again, it's similar to the Motorola 2N3904, but look at the frequency. It's not 1 megahertz, it's 976 kilohertz. We'll get into a little more of this, why these are happening when we're done. Last but not least, let's try our germanium transistor. This is a PNP germanium transistor we're going to put in. Okay, this is a Russian germanium transistor, and it's a, I don't know, it's that, I'll show you, that you can look it up. Wow. Now first of all, it is ringing at the bottom a little bit, and you are getting some clipping down here, but look how nice and clean the rest of the waveform is. However, look at the frequency. It's way down. 870, what, 77, 880 kilohertz. All right. So we can look at this from one of two perspectives. Number one, we could say the circuit is flawed, and if you adjusted these components, or you added these components, or you did something different, you could get that waveform to clean up and look correct. But that's not what I care about. I actually did not care about how perfect that sine wave was. What I cared about was that our original transistor, the NTE107, let's just say, hypothetically, that the circuit was designed for that transistor. And you notice what the waveform looked like. It was not a perfect sine wave. However, it had a certain waveform to it, correct? All of the other transistors we put in there, not only did they affect the shape of the waveform, it affected the frequency. So each transistor was slightly different. Each transistor affected the circuit. In some circuits, it won't matter. In other circuits, this does matter. As you can see in this particular circuit, it matters. If we wanted a specific frequency and waveform, and we changed the transistor with a different type, it would affect the circuit. Now, why does it do that? Well, a transistor is not, a lot of people, you hear comments, what is a transistor? Well, it's just kind of like a switch. Well, that's not true. It's not completely true. And there's much more to a transistor than just how many volts and amps and watts it can handle, and what frequency it's rated at. The transition frequency, the Miller capacitance, there's different characteristics in these transistors that will affect a waveform when a AC waveform is applied to it. Now in DC electronics, that's different. It affects that too, but more so it affects in the AC world. And that's why it's really important that the transistor you choose for the circuit matches the circuit as it was designed. So you can't always just randomly put in a transistor. And that's why you really have to try, if you're going to substitute a transistor, especially in a radio circuit, it's much more, you will notice it much more in a radio circuit than you will in an audio circuit. Although this same thing applies to audio circuits in some instances. It will make a difference in the sound, especially if you're a critical listener and you have the right type of setup to be able to hear little differences. You will. And that's not snake oil, it's the truth. I can't hear a lot of it because my ears aren't refined anymore, and I don't I'm not a critical listener. I'm not someone who does that as a hobby, but you can. So bottom line, different transistors can affect the circuit differently, as we found, and it's really interesting. And I thought, as I did this experiment, I thought, what the heck? Let's do a little video on it. So there it is. I hope you enjoyed it. I hope it was fun. I'm not going to get into any more details of anything else. I'll leave it open to discussion. And hey, that's how we learn, right? Instead of just Googling it, I built it and we tried it. And that's what I like to do at the bench here. That's what I enjoy about this hobby. All right, take care, everybody. I wish you all peace, joy, happiness, and good health. And we'll be back on our original project here real soon. Take care. Bye-bye.